So I will use the microphone. I have no choice, isn't it? So I will skip the survey due to all the noise. So we'll go straight to the actual talk. So what we see today is that clouds are used more and more. And so if you want to find out how much at the university here clouds are being used, you have to look at the IP addresses of the different services that the university runs, and you will find out most of them, maybe Caillou is an exception, but most of them are actually outside university due to clouds. And so that happened under the Obama administration for the US government. And so the Washington Post wrote the US government is also getting ready to move about 75 agency-identified programs to cloud. CEO's University College London was one of the first universities in the United States, in the world, sorry, actually that decided to use Hotmail. They claimed that saved 2 employees, which I strongly question, because it costed, they actually had to hire a lot of people to teach them how to switch to the Hotmail. Now, the customers, their impression, can everybody see, or is it too bright? Okay? So, customers' impression is that if you use the cloud, there is no need for backup. And since Belgium is a part of NATO, US clouds are considered trustworthy since they are US based. So, if you don't believe in all this, then you could say, can we actually trust the cloud? And you could go further and you could wonder, can you actually trust your operating system? And so my NSPW 1993 paper, in that I actually questioned whether we could use an OS and whether we could actually trust that OS. And so what I actually said is that the only thing that you could trust, and in particular when you're an electrical engineer, you can open it and see what's in there, but nowadays there's much more electronics in, is to say, I trust the keyboard and I trust the display. We'll talk about that later, about saying, what are you going to do if you don't trust the keyboard? And in particular, what if you don't trust the display? So that was the idea in my 1993 paper. And so that means that by not trusting the OS, everything had to be encrypted. And so it's actually the first paper that talks about searchable encryption in my 1993 paper. It was more a paper about open problems. And that's why I didn't send it to crypto, because it was only in the 70s that papers that actually were about open problems, as Diffie Hellman's paper, were considered of value in the crypto community. So, in that, I also proposed the idea of the functional encryption, and evidently the name was different, it was called operator-oriented encryption. So, during the evening, people wondered, how are you going to now realize this untrusted OS, where you only trust the keyboard and the display? Everything you type on the keyboard would be encrypted. Every command that you type would also be encrypted. And then you would actually also sign that and authorize the OS to make the change into file. So you actually had to work on an encrypted file and then do these operations and transform that into new signatures for the new document after the authorized signatures have been applied. This problem has still not been solved, okay? So if you're looking for natural problems in doing that on a SQL server, then you can look at that paper. So during the evening in the bar, people said, how do you think to realize that? And I said, yeah, doing MPC. But actually, we never wrote it down in the paper. So there's no trace of the idea of realizing this, using an untrusted OS to make a trusted OS by using MPC. But actually I had thought that I had published this earlier on, and there is evidence that in lectures that I've spoken about. So I've been looking, so recently over summer I met Yvo Desmedt, and I was talking about this in the context of what Nigel Smart had said, saying, look, we don't have key applications for secure multi-party computation. And then I told him, said, hey, what about making an OS? As I had written in '93, he said, send me the paper. Then I realized I never wrote it down. It was a discussion in the bar. So in 2003, so I searched all my files. So I found a file from September 17, 2003 that contained trusted computing using untrusted platforms. Okay, so I gave talks about it. And also in the context of communication, we were looking at PKI. How can you combine untrusted PKIs to make one virtual trusted PKI? Also for communication in the context of PSMT, all these issues were discussed. So I presume most of you here know what secure multi-party computation is. So I skip that. Now I'm going to talk about that MPC is different from secure outsourcing. So if you don't trust your OS and you want to use MPC to actually become a trusted OS, then you're actually doing an outsourcing. You don't do your computation. So if you have a laptop, then what happens is that you actually don't use the OS on there. If you outsource, and that's why I was talking about the cloud. But the question is MPC the same as outsourcing or not? And there are dramatic differences between them that we now need to talk about. So every time you use the cloud, you outsource. I mentioned that in the beginning. When you don't trust your OS, what you could do is say, hey, I'm going to use several OSs, let's say Microsoft, and then Unix, etc., and then use MPC. But it's not, doesn't fit 100%. So I'm going to explain why. So the idea to have a primary single party outsourced reliable computation is done in any Boeing 777, Airbus 300. So what they actually do is they use multiple computers, they also use multiple software, and multiple platforms. And adding privacy to this was actually done in 1980 by Yvo. And so on June 7, 2011, I gave a lecture at a workshop Secret Sharing and Cloud Computing on secure multi-party computation to protect cloud computing. So at that time, I used to believe that secure and reliable outsourcing of computation was equal to MPC. So then, with the recent progress, or lack of progress, if you look at what recently has happened with all these things being broken, on functional encryption, it reminded me of my old work and my 1993 paper that I mentioned earlier. And then actually that inspired the work on computing functions of a shared secret, which are now called functional secret sharing. So a moral description of functional secret sharing is that you have a secret S, and you're going to share that out, and now what you actually want is not that anybody or authorized people can recover S, but you only want that they can evaluate f of S for certain functions f, and not others. Okay. So this is very close to functional encryption, but then with secret sharing. That paper, which we talked about in '93, inspired by my earlier work I mentioned, got published in 2000. Yes, sometimes it takes the community a long time to understand new ideas, so this happened in that case too. So how does it differ from secure multi-party computation? So the main approach is to be non-interactive, which we think is more realistic. If you look at Google and Microsoft, many people view them as free cloud servers. Do you really think that these free cloud servers that they actually will now start interacting with each other because you want to do some MPC? I don't think so. Okay? So therefore we focused, at least Mike Burmester and me, two of the authors of that paper, focused on non-interactive part. So there's also a fundamental difference, is that secure multi-party computation requires that nothing leaks about the input. But if you outsource, that requirement is not needed. Because what I will have data that I will outsource to the cloud. So then I give shares to one cloud server, a share to another cloud server, a share to a third, etc. Now suppose that those cloud servers are going to do some MPC on this, because I want to outsource not just the storage, but outsource also the computation. Eventually, the full OS, okay? So then, the usual requirement of MPC, it shouldn't leak anything about the inputs. The inputs in this case being shares, but that's not correct in this context. What they should not leak about is about my input, clear? Which is different than the shares, which are the inputs to the MPC. So you have a relaxed condition that you don't have an MPC, clearly showing that the two are not the same. There are more examples going to come, showing that the two are actually quite different. So our model in this 2000 paper allows some information to leak about the inputs, namely the shares, provided it doesn't leak extra information about my input that I've shared as a dealer. So you could wonder whether there are any limitations. So this is similar to functional encryption. And what we were shown a long time ago, actually, at Crypto 92, we showed that all these things work nicely without interaction, but at the moment that you have two inputs, the problem is the following. You could say, okay, if I have two inputs, I can abstractly regard them as one. Yes, up to the point that if you have an input now, so suppose that I have something that I'm going to share in the cloud, and then do computations on, and this functional secret sharing works nice, but now if I have another secret tomorrow, okay, and I'm going to share that out, and I forgot, because don't forget, today everything is stored in the cloud. You don't have any data more on your laptops. That's how many of these cloud servers work. So the dealer does no longer remember the secret of yesterday. Now he's going to share a secret of today. Oh, clear? So the first and the other are on different days. Now if you want to then compute a function on both, can you do that without interaction? And the answer is no. And that was proven a long time ago at Crypto 1992. So single operational homomorphic secret sharing can be done without interaction, but if you want to do more than one, then the answer is you need interaction. So there's also a major difference between MPC from a dimensional viewpoint, because in MPC you're going to have n parties. In outsourcing, you're going to have more. You have more dimensions, and the reason is that when you have two parameters, not just one n, and you have n servers and n secrets. In the case of MPC, they are the same. You have n parties, every party has its own secret. Clear? In outsourcing, you don't trust a single cloud server. So what you will do, you will use cloud servers, and evidently you will not do what I said, that you will only use US cloud servers. You will actually think about cloud servers that are not based in the United States. And then that means that you want these n servers, but then the secrets don't come from the servers, as in MPC. The secrets come from a party who wants to store all that and then use the servers to do outsourced computation, so you have n servers. What that truly implies, we haven't thought that through. Okay? So there are definitely lots of nice things to do to look at outsourcing versus MPC. So first of all, what people usually use when you think about MPC is a threshold. Say, okay, we're going to use threshold because that's nice. So what happens is that, as you may know, Huawei is now being boycotted in New Zealand, in Australia. Now, I heard recently in Europe, the US is putting a lot of pressure on the European and worldwide Western governments to boycott this cooperation. Now that's actually not new, because a similar investigation took place in 2013, and then what happened is Parliament learned that British Telecom already had made an agreement with Huawei to actually use their equipment. I think that was made around 2008 or so. So this was actually quite late. The British government found out that British Telecom was actually using this equipment. So today there's a fear in the West of Chinese equipment, but similarly in China there's a fear about them using Western equipment. So how can we deal with that? So the solution is that we proposed in 2004-2005 a model to actually deal with that. And so what we do, we cover parts of the infrastructure. So in this case, the nodes are computers. And so the communication links are the edges. And we do that with color-dependent colors, country-dependent colors. So if you use a Huawei equipment, then we color that, for example, red. And if you use some other equipment, then you can color it green or the blue or yellow, etc. And so, for example, here is a network in which you see that the nodes between A and B have been colored. And so you could say the Huawei nodes are red, Cisco nodes could be yellow, etc. And then you basically color all these nodes. So now, if you have two countries that collaborate against, basically want to shut down the communication between A and B, there will still be a path left over that you can bring you from A to B. Clear? So this is a very different access structure than actually saying we trust T out of N as an ordinary threshold secret sharing, because this one here is going to be color-based. So what we suggest is that you're going to go to outsourcing your computation, that then you also color the platform. So if you use Windows, so if you make 100 copies of Windows, that's the same under that model as having one. Clear? So if you have a share, if you have a secret, and you share it to 100 Windows, which are the same platform, that's the same as just giving one share with this color-based access structure. So MPC is totally different from outsourcing, from secure outsourcing. And we are now going to talk a little bit about that. So when you take a course on reliability, the first thing that you actually learn is that you're going to replicate this computation, as for example happens in a Boeing, in an Airbus, etc. So in military airplanes, they actually use 4 computers. In certain military airplanes, they use 4. So that if you have faults on 2, then you can then still detect that. If you fly commercial and you have 2 faults and they give you the same fault, that will be the majority, and so then the plane will make the wrong decision. So, but what do you then have when you fault? So every time that you have outcomes from these 3 computers, you will fault. The majority is what's being chosen. What they then teach you in the course on reliability, class 1, is that for the voting circuit, that has to be 100% reliable. Okay? What does that imply when you're looking at outsourcing? So, okay, so let's now look at this. So that means that if I'm going to have a display, and then you could say I could have 3 displays, but that will not be user-friendly. Okay? So if I want to combine all this in one display, then that circuit that does that has to be 100% reliable. So that means not only reliable, but also private. So that means that if you look at the last stage in MPC, that is Lagrange interpolation in the passive case, and the active adversary, you have to do something as Berger-Massey or another error correcting. Clear? So that that means that this Lagrange interpolation has to be 100% trustworthy. Now for KU Leuven, that's easy because they have IMEC, and so you can make your own hardware for actually doing Lagrange interpolation on a trusted way. But, okay, good. So, but there is electronics here in Belgium to do it. But many places in the world, I was giving a talk in India, they can do certain things in hardware, but not up to the standard they would like to. And if you go to many countries in Africa, forget it, they cannot build their own hardware. And so they do not trust the last stage of MPC, which is doing either your Lagrange interpolation or doing the error correcting together with Lagrange interpolation. So that is a serious problem. And so that is obviously has been overlooked. So I mentioned both cases. So now let's talk about solution to this problem at a high level. So Motti Jung, at a conference in Beijing many years ago, suggested that China build their own Lagrange interpolation. There are several problems with that. So one is that due to outsourcing, we're now talking about outsourcing not of data, but of manufacturing, places that used to be able to build certain technologies, they no longer exist. Not all countries can do that, I mentioned that earlier. And it only deals with passive adversary. If you have active adversaries, Motti Jung's solution will not help. So our approach is to actually use the human brain. So the problem is that humans cannot do Lagrange interpolation. Clear? We cannot do that. We are not smart enough, or it's too complex for us to do it basically out of our head. And we definitely cannot do it on decoder. So the solution that we actually have proposed is to design special secret sharing schemes so that this recombination can be done by a human. And so the question is then, how realistic are our secret sharing schemes? And so we tested that in a specific context that I will mention later on. And we had a 99% accuracy. So we also have done the same in the active adversary case, where we use secret sharing schemes in which we can deal with errors using a variant of repeat codes. But for those, we haven't tested how reliable they are and how good humans can do them. So I will first start with explaining the passive adversary case. And so that was developed by my former student and myself at SCN. And so I'm going to explain now how can you combine shares by a human. And so that was actually in the context, so if you look at the title of the talk, it talks about outsourcing MPC in the context of untrusted OS and untrusted apps. So this app was Walking App. And so this was, the names here came from the ICR election. So we have the names of the candidates. So my student put colors there. There should be no colors on this slide. So sorry. If you are colorblind, you're better off this time than people who are not, because there should be no colors on this slide. It's a mistake my student made. So this is basically what you paste on your website. And it says, do not vote without sheet 1 covering this area. And this is another one that says, do not vote without sheet 2 covering this area. And then here you see basically radio buttons that you can push. So now what happens is that a share, in our case, is nothing else than a permutation. No colors, okay? Forget the colors. So that's a share. And now it also says, put this edge against the candidate list, and then put the other one against sheet 2, so it's easy to paste that there. And then there's another one. This one you print at home, the other one you print in the library. And boom, what humans can do apparently is compose permutations. Clear? And so we tested that, 99% of the people were able to do this. So if you want to vote for bad, you just follow the line, forget the color, there are no yellow, okay? The yellow shouldn't have been there. And then you push this button here, and that's a vote for bad. So, no need for a large interpolation, as you see, and composition of permutations is easy. So now, when I was giving this talk at NIST, René Baralter said, so the problem that you have in the previous one is that if you look at the group of permutations, they are non-abelian. And if you look at signature and you're dealing with things that are non-abelian, it's very, very annoying. And so you get nicer schemes, in particular in the context of voting, etc., when you want to tally and all these things, when you have things that are abelian. So René Baralter had a comment and he said, hey, if you look at the abelian group of the integers modulo 10, then nothing else than a subgroup of the symmetric group over 10 elements, which is what the second line says. So now, if you look at that one here, that's nothing else than an addition. So your 0 is not mapped to 0, but it's mapped to 1, 2, 3, 4. So this is plus 4. This permutation is a plus 4 permutation of 10. And this is a plus 3 permutation of 10. So if you put the one after the other, you do plus 7. Okay? We asked people to actually also do computations mod 10. And then basically we took a random audience and asked them, only 95% of people were able to do that. Okay? Because they're so used to work with the carry, now you have to drop the carry, that's hard for 5% of the people. So once we did that, then 99% of the people were able to do that correctly. Okay, so passive case is easy. Now we need to look at active case. We haven't checked how good people can do that, because once you start looking at that, you say, hey, wait a moment, this is actually quite complex. And so actually what we're using an idea that Kurosawa and myself had in our Europe 2000 paper. The part, I think you were the general chair, program chair, sorry. It was in Belgium, in Bruges. And so there we actually we define what we call verifier set system. And in the paper that I mentioned with the Stelios, then we generalize that. So in combinatorics, you have so this idea is actually coming from combinatorics. So you have what's called a set system. There you have a set, and then you have very special subsets, and you call them blocks. They're not any subsets, they're special designed subsets, and they form what's called blocks. And then you have a collection of those. So a set system is a set with a collection of special subsets. And so then what we actually did is we introduced a special one of these, which we call an NBT verifier set system, such that the cardinality of x is n, that's the n parameter there. The cardinality of each block is exactly t plus 1. And for any bad set of the bad guys, and we know we have less than t bad, there's going to exist one block which is completely free of the bad. Clear? So your blocks are specially designed so that whatever the bad guy is going to choose, there will always be a block which is free of bad. So Panos, some of you may know Panos from Stockholm, he read this paper and he said this one actually my best papers. But yeah, nobody knows about this. Sometimes it's crazy. Why certain papers get cited and not. The consequence of this is that you now can do voting without the need for zero knowledge. There's no need for zero knowledge. Okay? Because one block will be free of the bad ones. So you don't need all this zero knowledge stuff. So in this context, we slightly generalize that. And so we introduce, so instead of having So we have two t's, a t and a t prime. The size of all the blocks are t prime, and the bad set is of size maximum t. Small generalization. Then we made a link with covering designs. So those of you who are not in combinatorics, so a collection C of k subsets called blocks is an nkt cover design if every t subset of 1 till n is contained at least one block. And so already there was a link made in the 2000 paper, which now is generalized. And so we now get that an XP is a generalized NB T prime T verifier set system, even only if the set system XP complement is V minus T prime minus 1T covering, where the complement is that we're going to do. When you have a block in the complement, you're just going to take the complement subset. Clear? So if this is in the block, that means it's a subset of X. You then take the complement of that one, and that's going to be the complement block. So the link with covering designs is quite strong. And then we actually use that in the context of private and secure message transmission. Our goal was to use that for the basically voting. So what we now do is the following. So when we have this communication that takes place, and you can also think about that, that when you actually think about outsourcing to servers, that the lines that you have between S and R, that those are servers between, instead of nodes for communication. Then you're in the context of OS. So the secret will be shared using secret sharing, and so underlying is a P out of P secret sharing scheme. Okay? So permutations is easy, etc. So making P out of P secret sharing scheme, you can do with minimum amount of algebra. So now what's going to happen is that these, so each of these P shares will be transmitted over a block of wires. So let me use the blackboard here. So you basically have here this fixed set X. And then as it says, each of these B shares will be transmitted over a block of wire, with each share transmitted over one block only. So each block will correspond, so this is X, and this is, let's say, B1. To this B1, those are the, so X are actually corresponding to the numbers of the wires. And so this is a subset of the wires. So that's why I said this is similar to a repeat code, but it's just back from Australia. If you go to a village which has Aboriginal heritage, then instead of calling the city Leuven, they call it Leuven. Okay? So that way, they do a transmission, which they may have been doing using smoke or whatever. If they make a mistake, they can at least detect that the mistake was made. Okay? So repeat codes are very old, much older than we actually think. So now what you will do, so over these wires, you will repeat, so over this block you will repeat the share, you will send it over all these ones. Now observe that if you look at this wire here, this wire is in two blocks, clear? So this wire will get and this share and that share. Now if you look at the bad set, suppose there's a bad set. So those are the eavesdroppers. So what's going to happen is that now, these eavesdroppers, there will be one block which will be free. So there exists a block, Bi, which is free of the bad. So that's the only thing that we actually need. But that means that then the person has to use this repeat code in order to find where this one is. And evidently we have conditions on T prime. So what we have is that each block will be of size at least 2T plus 1. So there's an extra condition. So majority can always be correctly received by the receiver, allowing error correction by the receiver. Now I went to a conference in Bern a few years ago, where we were lucky that the person in charge for electronic voting of Australia attended. And he said the situation is really bad, because some of us think that we could go back to paper ballots. He said, forget about that. Today, most people can no longer count. Okay? So, it's shocking, isn't it? And so he said, if you would give people, let's say, the 7 ballots, and 4 for the yes and 3 for the no, you're not guaranteed that you will get the correct reply. Okay? So, making majority may not work. Now, I spoke with people about this. I said, yeah, but at least, Yvo, if you look at what the people who are looking at human aspects of security are doing, they're actually testing this out and finding out how many people can do such things. But we haven't spent the time on that. Also, in the meanwhile, my former student, graduated. So I have to find somebody to actually continue with this type of research, then test how good people can actually put that into practice. Okay, so you see we are far, far, far from an OS, because imagine that you want to do that for an OS where you have millions of operations that take place, and now you want to do this computation by hand. Clear? So the computations will be done. So there have been schools, in particularly I visited people in Italy, that are looking at MPC by hand. This is not MPC by hand, it's MPC by computer. It is just that then, if you don't have a trusted combination, can you deal with this? And yeah, you can to some extent. And for a thing as voting, which is a very limited application, it's not a problem. But if you want to do that for OSs, then this is a problem. So, now one thing that we also can look at is that in the application that I mentioned, our permutations, our shares are actually permutations, as you see here, our shares are permutations. So then the question is, can you actually do computation with MPC, with permutations? So you start having shares that are permutations, and then actually do MPC with that, which is a problem we solved roughly 10 years ago at Crypto, in which we showed that you can actually design protocols that work with any non-abelian group, and that actually leads to very interesting graphs, which I don't have the time to go and explain. So, but if you're not familiar with that, you're welcome to read this paper. This paper was then improved slightly with joint work with Andreao and appeared in Journal of Cryptology. So let me come to the near the end of my talk. So when you look at outsourcing, it's obviously that there are a lot of open problems. So first of all, related to functional secret sharing, I mentioned the open problems in that context. So our approach requires the human involved in human computation. So the computation will be done by computer, but then at the end, to combine the shares, you need a human computation. Obviously, the question is whether can this be improved or avoided. So what we really want is at the end stage that then you actually obtain visual crypto. Because if you have visual crypto shares, you could combine them as in Nauer Shamir, and Nauer Shamir is actually a reinvention because this idea was proposed earlier on also by people from Israel, but unfortunately they published this in a Journal of Physics instead of in a crypto community, and they ended up in only 2,200 citations, even though they were first. So that's a side note. So we would like to have MPC in which at the end we get visual shares, which would make it easier to actually then combine them and avoid that we have to resort to humans combining them. So, as I said, there are other people who actually say, can we do all the computations using visual crypto? There have been people who have looked at that, but that would be evidently too slow. So we want to do ordinary MPC, but then have these special secret shares. the problem with that approach is that you're dealing with incompatible secret sharing schemes. And so we tried to do that with permutation. That's why we had to reinvent the wheel and make special MPC for doing that, which was a paper at Crypto. So yes, there are, as I said, the title of this slide is Open Problems. And then finally, even if we solve the problem of making distributed OS using MPC fast, which is really a problem, okay, because MPC is not very fast, we still have to deal with making the keyboard. That is the main problem. How can you make a trusted keyboard? Okay? So it reminded me a little bit, I think it was Bruce Stein. So Balaton at the lake, were you there when Eurocrypt took place there? So in our room we had an old-fashioned radio, and for fun I told somebody that it must be full. So basically this building was the former the summer palace of the Communist Party, and so I told somebody it must be full of eavesdropping devices. So I took mine apart, I opened it, and then I saw a whole bunch of vacuum tubes. So I said, I'm not going to take that apart. But I think it was Bruce Schneider who took the whole thing apart, and then concluded and saw me the next morning and said, I didn't find any bugs in there. So, but that's basically the keyboard. If you buy a keyboard, if you buy it over the internet, then how are you sure that NSA didn't put a bug in there? Okay? So, so it's not so easy. One thing you could do is say, hey, I'm going to go to an antique shop and buy keyboards from 30 years ago, which at least you can open up, not too much electronic things, and then verify and close. And since many of you here are electrical engineers, for you it's actually not too difficult. It's actually fun opening the keyboard, so I've done it a few times. Be careful if you don't know what you do, because putting it back together is actually not so easy. But that's a problem. And also in Shamir's secret sharing scheme, Nauer and Shamir, they assume that it's a trusted device that actually is going to make the shares. Okay? So that if you don't trust manufacturing companies, and that's a big, big issue now with all the things that you see in the news, with Huawei being boycotted by basically Western telecommunication corporations. And the same is happening in China, by the way. Okay? It's not just that the West is afraid of Chinese equipment, China is also afraid of Western equipment. So, if you buy a keyboard, yeah, you have to trust it. Is there a solution? I don't know it. Okay? So, but that problem is, in this case, you need a very special keyboard, because that keyboard has to make shares. Okay? I hope you understood that. So it's not just an ordinary keyboard. That problem hasn't been solved. Hasn't been studied so far, and I don't know a solution at all. Okay? So outsourcing is not so trivial. So who observed this problem too? I actually mentioned Montaigne. That in 2014, I visited the funding agency in Washington, D.C., and I spoke to a program director of DoD, and he also had observed that. So I presume that he just got a proposal saying, hey, why don't we just use an MPC and replicate the computation on many platforms, on many computers? He figured out that that wouldn't work, because how can you just, if you replicate and you have one fault on that computer, you will just replicate the fault. Or if there's a deliberate bug that was being put there as station-sponsored malware, you will have station-sponsored malware on all these replicated machines. So then I told him that we had thought about long before him with his scholars, but then he had also observed how do you actually combine these at the end, because that part has to be trusted. So there are at least two other people who talk about. So the conclusion is this. And I'm going to quote Joan Feigenbaum in her talk that she gave in Cambridge. Free corporate-based cloud services are not free to our society, which many people don't realize. So these companies, they actually get a lot of information about you, and so therefore they are not free to society. You completely lose privacy. So the second conclusion is, should posting by children be censored. That's related to part of the talk that I removed. So that's conclusion I should have removed. Sorry for having done that. So when I visited Google a few years ago, I actually asked them the two questions. So one question was, will Google still exist in 10 years? And which they said for sure. Then I asked them what happened to DEC and SUM. I said, oh, we didn't think about that. And my other question was, will Google be Chinese in 10 years? And they also said for sure not. In the meanwhile, a part of Motorola that was bought up by Google was sold to a Chinese corporation. Okay? So not sure that Google will actually still be US. And so if you use a single cloud server and you put all your data in Google today, that may become Chinese tomorrow, or maybe Russian in 15 years, who knows, okay? So if you don't trust the Chinese or you don't trust the Russians, then putting your data in Google is a bad idea. So we definitely need to go to trusted outsourcing. Outsourcing of storage, but also trusted outsourcing of the OS. So we need peer-to-peer, personal, cheap, easy-to-use cloud servers, that's for sure. Because whatever you're going to do, and tell everybody, and Bart is very great, every time he gives a talk, he says, don't use clouds. But Bart is not the Prime Minister of Belgium, and even, I think the Prime Minister of Belgium, even if the Prime Minister of Belgium would say, don't use cloud servers, he's not the President of the EU. So you need someone who is the President of the EU saying, don't use cloud servers. As long as that doesn't happen, CEOs everywhere, management, all going to go to cloud servers. Microsoft today, the profit that they make with selling operating systems is 10%. All the rest they make with outsourcing. Okay? So we are definitely in a different world. So we definitely need to look at making outsourcing secure. I think that secret sharing is a useful tool, but share should be on servers of different entities, such as different companies. I mentioned that earlier with my colors. For non-US countries based in multiple countries. And secure multiparty computation is a nice setting, but the free setting requires servers to interact is unrealistic. Functional secret sharing does not require interaction. Unfortunately, there are limitations. Some that I mentioned. Also, the size of the shares grows enormously. So requiring secure computation might be too stringent. I mentioned that earlier. Conditions are not the same in outsourcing as they are in secure multi-party computation. That nothing leaks about inputs. You don't have it in outsourcing. There are many other problems in secret sharing-based solutions when you think about outsourcing, secure outsourcing. And since in our area it takes a while before research is deployed, think twice before using the cloud. Okay? Make sure the CEO knows this too. And under Obama's cloud first policy, NSA succeeded in convincing the Obama administration not to use a cloud server for NSA data. So you may not like NSA, but at least you can use this sentence as a reason to say, these people are smart, we should be smart too, and until there is no good solution for dealing with outsourcing, we should avoid using clouds. And obviously, I think solving this problem of obtaining secure outsourcing is, I think, an important problem. Eventually, we may use some parts of MPC, and that's why I said to Yvo Desmedt, it seems that the community is not aware of that this could be a key application for MPC, but then it turned out, I never published it, it was just a discussion in the bar. And yeah, it was good to actually then try to send this paper to Yvo Desmedt, to actually then realize, hey, wait a moment, I never published this idea. Okay, that was the end of the talk.
We also have many unpublished papers written in the metaphor every Friday evening. So questions for Yvo? So if I combine the results with Windows, Linux, and iOS, can I not check that the combination is correct? Because I assume that they're kind of independent.
So what happens if you're going to use this sharing, then you will have to use this avoiding all the time, where you do 2t plus 1. And so that means that provided that you assume t of the servers are maliciously giving you incorrect results, then that way you can still get
You
the...
have to give the same result. If I have 3, 2 give the same result, then I'm okay.
Yes, so the problem is indeed, what size of T do you actually have to choose? And I'm actually, 10 days ago I was in New Zealand and I was actually looking at that. What value of T is the right value? And I've been looking at that since the mid-90s. Spoke with many people about that. Now maybe we'll come to a solution on what size of T should you use. So one thing that we should also learn from that is that at the moment we have very, very few OSs. So we should encourage, China is making its own OS, but so far I know the EU is not. So we should encourage the EU to make as many new OSs as possible so that then we can use more. Now, evidently there are, the problem is that if you have an agency who can put a spy, an active spy, in every organization that's going to build a new OS, yeah, then you're dead, okay? So the problem in practice is harder than it looks on paper. On paper it looks already very hard, okay? And we are really very far from that. But I think that with the fact that we outsource so much of our computation today, not just our computation, we outsource so much of our storage, it's actually shocking how much of things that used to be done on paper are now done on computer. But you would think that they would actually be done on a computer from the organization, but the way they do it, that organization shares it out. And so cloud servers, as I said, Microsoft, 90% of their profits come from cloud. So yes, we really have ignored something that we really need to address. Even though it might not be perfect, but at least there's a difference between just sitting there and saying, oh yeah, or saying, we have this whole thing about MPC, can we now at least move in that direction, the right direction, and then instead of just sitting there as we are doing now.
More questions?
Thank you for your attention.